continue that yesterday at the end. So this will be in stability module, and also these different circuits are acting as filter circuits. So in general, especially RLC circuits is the crux of this entire subject. So we discussed performance of RLC circuits on sinusoidal input. So we noted two things. Number one is that when I apply when I apply a sinusoid circuit, say sinusoid input, the circuit consists of R, L and C, and also adder and amplifier. If adder and amplifier are there, it is called an active circuit. If they are not there, it is called as passive circuit. So the concept of circuit in the subject of circuit theory, circuit means a composition of R, L, C, scalar or amplifier and adder, where scalar and amplifier or adder are operational amplifier based. I have provided you 3 video lectures which will clarify operational amplifier to the extreme simplicity. I suppose that you have gone through them. So that circuit includes all these things. To that I apply now a sinusoidal input. When I say sinusoidal input, this is, I can say that sine omega t plus phi may be there, and I can have this as something called as some amplitude. I need not apply only thing with amplitude 1, it can be of some other amplitude, right? So this I can say, I will provide you some A in order P. So if I apply P sine omega t plus phi, listen now very carefully, then any circuit which will include, if it is a only resistor, it is not to be discussed. It's very simple. But if it includes either of capacitor or inductor or both, and in some cases adder and amplifier, it may or may not be. So in general, a circuit includes that. Output is always a sinusoid. Output is always sinusoid, and the output is, let us say, Q again sine of omega t. It is in here, I can say, I will use word theta here. P sine omega t plus phi. Output will be Q sine omega t. Sorry, it will be P sine omega t plus theta. Output will be Q sine omega t plus phi. Is it right? So while now, means say 3-4 decades back, what are you doing? Look here. 3-4 decades back, ability to compute something was considered to be a good skill. But now that is no longer. So you may not be able to get the exact answer. But if you are able to understand, what is understanding? What? Since differential operator is a scaling operator, listen very carefully. Differentiation of one sinusoid is always a sinusoid of same frequency with different amplitude and different phase. If I add 2 sinusoids of same frequency, I always get the sinusoid of same frequency and different amplitude, different phase. लक्षात आलं का? म्हणजे दोन sinusoid म्हणजे काय? A1 sin omega t plus theta 1 plus A2 sin omega t plus theta 2 is always equal to A3 sin of omega t plus theta 3, where A3 depends upon A1, A2 and phi 1, phi 2 also, and theta 3 depends upon all these 4. लक्षात आलं? म्हणजे दोन सिनुसॉइड इज कॉल्ड एनालिटिकल सिग्नल. म्हणजे जसं किती वेळा डिफरन्शिएट करा, किती वेळा इंटिग्रेट करा, आउटपुट ही तीच साइन वेव्ह राहतं. मग सर्किट मध्ये आपण ऍड होऊ शकतं. ॲम्प्लिफायर असेल तर मल्टिप्लाय होऊ शकतं, कॅपॅसिटर इंडक्टर असेल तर इंटिग्रेट किंवा डिफरन्शिएट होऊ शकतं. पण सगळं जरी झालं तरी शेवटी काय, एकूण आपण सिन्युसॉइडमध्येच राहणार, राईट. सो अल्टिमेटली the output of any circuit which includes, आणि हे लिनियर सर्किट आहे, यामध्ये डायोड चालत नाही. In linear circuits R, L, C, amplifier acting in linear domain appropriately, and adder. So output is always a sine wave Q sin omega t plus phi. But what is important is that this Q depends on what? Obviously P and omega. So if I divide Q by P is called as amplitude gain. In most of the cases it is actually loss because it is less than 1, but the term is gain. लक्षात आलं? म्हणजे कुठल्याही लिनियर सर्किटला सिन्युसॉइडल इनपुट दिलं, आउटपुट सिन्युसॉइड येतं. तर आउटपुटची एम्प्लिट्यूड भागिले इनपुटची एम्प्लिट्यूड, राईट, इज कॉल्ड एज एम्प्लिट्यूड गेन. अँड phi minus theta is called as phase shift. त्याला phase gain ही म्हणतात. And what is important is both amplitude gain and phase gain. Amplitude gain आता P अवलंबून नाही आहे कारण ते P डिवाइड केलेला आहे, right? So gain is not dependent on P now. P, because we are comparing to what extent compared to P it has increased or decreased. So it is now independent of P. So amplitude gain and phase gain both are functions of frequency. It is called as A omega. The symbol and it is called as phi omega. So A omega and phi omega are functions of frequency. Means for one frequency, if I apply the signal of constant amplitude, for one frequency output may be somewhat less, for some other frequency it would be much less. Is it clear? And there will be phase shift between input and output. This is called as a all circuits which involve either of L or C are frequency selective circuits, and these are called as filters. Means they provide a differential treatment for signals of different frequencies. Low pass filter, high pass filter, band pass filter, band reject filter. Right? Means they tell us how व्हिडिओ मध्ये तुम्ही बघितलंय, मी व्होल्ट मीटरचा व्हिडिओ सांगितलं, तो बघितलाय? व्होल्ट मीटरचा व्हिडिओ बघितलाय? व्होल्ट मीटरचं मॅग्नेटिक म्हणजे इलेक्ट्रो जो वे असतो जुना, आता डिजिटल नाही, कन्व्हेन्शन अॅनालॉग व्होल्ट मीटर, तो व्हिडिओ बघितला का आहे का नाही तो व्हिडिओ? So A omega and omega frequency, right? If it is like this, it is low pass filter. If it is like this, it is high pass filter. If it is sometimes it is like this, it is band pass filter. Sometimes it is band reject filter. Is it right? Achha na? So calculations and exact answer, I think now that is not need of the hour. म्हणजे ते करू नका असं म्हणत नाही मी, आता मी करा म्हणून तुम्ही करा नाही, हा भाग वेगळाच आहे. पण म्हणजे आता only sincerity is of no help now. You have to be very much smart enough. You now the question is, in few decades back the question of availability. Now the question of choice. How effective it means putting in efforts. Few decades back standard things were available for everyone, So those, since standard things were available for everyone, those who put more efforts were gaining more. Now availability of things is so huge that merely because you put more time and more efforts, you may not succeed. You have to put efforts and time in appropriate, what we can say, the appropriate direction and appropriate content also. So much things are available. Is it right? Is it okay? So this is filters. So you can think of any circuits and you should be able to plot. So now, once the things are given to you, R, L and C, one more, that is, and this. With these, you should be able to construct any circuit and you should be able to plot, find out. For P sin omega t plus phi, you can use what you can, for simplicity, you can make P1 and you can make theta 0. So use sin omega t, output you get something sin, in output you get something cos omega t plus something sin omega t plus something. That you have to, by using your all trigonometric skills. Now, or you can take help of ChatGPT. Means now, previous calculators were doing very, what we can say, numerical task. Whereas ChatGPT now is able to perform, this is non-numerical task actually. So, by the method I told, you can conclude to a sinusoid which is something cos something plus something sin something. That it comes, that adds up to some other thing, sine of omega t plus some phase. So this q and phi are nothing but function of omega, gain, magnitude gain and phase gain. Not magnitude. Sometimes it is used interchangeably. It is like this. Then, so this is filter. So you can go, so what will do? मी काय करतोय तर तुम्हाला असं पद्धतीनं हे केलेलं आहे की सगळं एकदम सांगतोय की आणि जे कळायला अवघड नाही असं सांगतोय. बाकी डिटेल्स आहेत ते नंतर कधी पण ज्याला आपण आता चित्र कसं काढायचं असतं तर चित्र काढताना काही चित्रकार काय करतात अगदी पहिल्या इथं सुरू करायचं सगळं डिटेल करायचं किंवा काही जण काय करतात ब्रॉड काढायचं सगळं ब्रॉड करायचं मग सोयीप्रमाणे वेळेप्रमाणे डिटेल्स करायचे. वी आर हॅव्हिंग ऑल ब्रॉड अँड देन वी पुट इन द डिटेल्स. आणि कधी कधी काय होतं समजा डिटेल मला वेळ कमी पडला तर अर्धवट काहीच कळत नाही पण मी ब्रॉड एकदा काढला असेल मग साधारण अंदाज आला असतो. इज इट राईट? देन नेक्स्ट थिंग काल जाता एक विषय असा होता स्टॅबिलिटी किंवा फॉर दिस सर्किट ते आता कधीच आलं नव्हतं. फॉर दिस सर्किट व्हॉट हॅपन 1 घेतलंय एल आणि सी घेतले की बदलतं पण सेम साइन ओमेगा टी आणि व्हीओटी काय आलं काल साइन ओमेगा टी 1/1 minus omega square. Is it right? Is it okay? So this was the means आणि हे काय आलं sin omega t plus काय नव्हतं प्लस नव्हतं हां प्लस नव्हतं. सो याचा a ओमेगा काय आला हा आला आणि phi ओमेगा 0 आला. Am I right? बरोबर आहे का नाही? चुकलंय हे बरोबर आहे ना? म्हणजे नो फेज शिफ्ट ओनली एम्प्लिट्यूड गेन. हा कसा येतो हा 1/1 मायनस ओमेगा स्क्वेअर काढलं तर ॲट ओमेगा इक्वल टू 0 काय येतं 1 ॲट ओमेगा इक्वल टू 2 काय येतं -1 बाय -1 मी आता प्लस किंवा मायनस म्हणजे इथं ऍक्च्युअली मायनस म्हणजे काय होतं 180 डिग्री फेज शिफ्ट येते. ॲट ओमेगा इक्वल टू 2 इट इज -4 सो -1/3. आणि ओमेगा इक्वल टू आता 0 पासून वाढत चालला ओमेगा काय व्हायला लागतं आणि ओमेगा इक्वल टू 1 कसा येतो हा काय होत तो becomes infinite at omega equal to 1, right? At omega equal to 1, the denominator becomes 0. So gain becomes infinite, right? And as omega becomes somewhat less than म्हणलं काय होता somewhat less than म्हणला खूप जास्त पॉझिटिव्ह आणि somewhat more than म्हणलं काय होतं खूप जास्त पण नेगेटिव्ह डिस्कंटिन्युअस फंक्शन तो असा आहे लक्षात आलं का as omega then at omega equal to 1 there is sharp discontinuity from minus infinity to minus infinity, right? Is it okay? At omega equal to 0 it is infinite, is it right? So that is the magnitude gain of the system is increasing without any bound, thereby leading the output to be infinite, which doesn't happen because of practical limitations, but theoretically it becomes so. So this is called as unstable system. What is the input amplitude magnitude? 1. Output magnitude becomes infinite. So for bounded input, if output is becoming unbounded, this is called as an unstable system. For bounded input, if output is becoming unbounded, this is called as unstable system. Laplace transform you have learnt. Laplace transform you have learnt. In the after midsem, I will provide you the interrelationship of all these things. But prior to that, so this is the only circuit. LC circuit is the only circuit which provides infinite gain. Other than that, if only RL, only C, along with R, all circuits are such that output is bounded if input is bounded. And this behaves unbounded only for a singular frequency. लक्षात आलं का म्हणजे फक्त ओमेगा इक्वल टू 1 ला याचं आउटपुट हे अनबाउंडेड होतं अनबाउंडेड होतं at all other it becomes range bound. हे पॅसिव्ह सर्किटच्या बाबतीमध्ये असं होतं इन पॅसिव्ह सर्किट्स LC सर्किट इज द ओनली एक्सेप्शन. मग ऍक्टिव्ह सर्किटच्या बाबतीत काय होऊ शकेल नाउ आय गिव्ह यू टास्क construct an active circuit for which output becomes unbounded. Active म्हणजे काय त्यात एम्प्लिफायर येणार ॲडर येणार आणि गेन तुम्ही ठरवायचा तर तुम्हाला ते लगेच येणार नाही म्हणून आता थोडा वेळ पण नाही आपल्याकडे. सो आय विल गिव्ह एक्झाम म्हणजे याला म्हणतात स्टॅबिलिटी. एक मॉड्यूल आहे मोठा सरकारने स्टॅबिलिटी बऱ्याच साधारणतः सहज कळत नाही थोडासा अवघड आहे काय स्टॅबिलिटी पण तो मी मॅक्सिमम सोपा करून सांगतो. आता असं घेऊया आणि पण घेता खूप सोपं घेतो बऱ्याचदा. Can you quickly compute? हे जर का तुम्हाला येत असेल मी जे रोज म्हणतो की मी असं शिकवतो की एखादं मी जेव्हा विचारतो तेव्हा त्याचं उत्तर येण्याकरता जे काही आवश्यक आहे ते आधी घेतलेलं आहे. हा माझा क्लेम आहे. आता हा क्लेम खरा आहे का नाही हे तुम्हाला उत्तर आता कळणार. V in T what I applied is this. So compute VOT. We take a pause for recording.